Hello, let's try to solve this polynomial inequality. So it says solve x cubed minus 2x squared minus 3x is less than or equal to 0. So as a first step, we're going to have to factor the polynomial as much as we possibly can. So first notice there's a GCF. Let's pull out an x, leaving us with x squared minus 2x minus 3. And then with the leftover quadratic, x squared minus 2x minus 3, we can also factor that, which means that we need to consider two numbers that multiply to be negative 3 and add up to be negative 2. So let's use x minus 3 and x plus 1. Okay, now that we've completed the factoring stage, we've factored x cubed minus 2x squared minus 3x into x times x minus 3 times x plus 1. We may now, if we wish, create a number line. This is what our textbook refers to as the algebraic method. So what are the three zeros or x-intercepts of the polynomial? Well, one of them occurs at 0, one of them occurs at 3, and one of them occurs at the number negative 1. Okay, so now on that number line, let's test a number in each one of these intervals to determine whether the polynomial is either positive or negative. I'll use red for this testing. So what's a number that you know and love that's bigger than 3? Let's use 4 as a testing number. And when I replace 4 in for x in each one of these pieces, you'll see that you end up getting 4 multiplied by 4 minus 3, which is 1, times 4 plus 1, which is 5. And 4 times 1 times 5 is 20, but all we really care about is the fact that it's positive. Okay, now let's take a number that we love that's between 0 and 3. For example, let's use the number 1 as our testing number. So again, plugging it into the first, the second, and the third piece here, we see that we get 1 times 1 minus 3, which is negative 2, and then 1 plus 1, which is positive 2. And 1 times negative 2 times positive 2 is negative 4, indicating that we are negative in this interval. Okay, I'm going to be a little bit more speedy on these other two, but if I were to choose a number between 0 and negative 1, I guess I would be taking a number like negative 1/2. And notice that in the first instance, negative 1/2 is negative, negative 1/2 minus 3 is negative, and negative 1/2 plus 1 is actually positive. And a negative times a positive is positive. And then finally, testing a number that's less than negative 1 might be like testing negative 2. And in that instance, we're going to get a negative and a negative and a negative. So our net result when multiplying them all will be negative. So overall, what do we have now? We have negative on the first interval, positive on the next, negative on the third, and positive on the fourth. We're looking to find when is the inequality less than or equal to 0. In other words, when is it actually going to be negative? And therefore, our final answer is going to be where the negative highlighting had occurred. Negative infinity up to negative 2. Sorry, not negative 2. Negative infinity up to negative 1, the border point. Union, where else is it negative? The other place it was negative was in here, that was between 0 and 3. And therefore that is the final answer to this problem, is negative infinity to negative 1, union 0 to 3.